Trigonometry, Chapter 3, Radian Measure in the Unit Circle, Section 2, Applications of Radian Measure, Video 2, Distance Between Two Cities. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we learned about the arc length formula. In this video, we apply the arc length formula to find the distance between two cities. To locate a place on Earth, we use latitude and longitude lines. Here's a picture illustrating each. Latitude lines are horizontal lines parallel to the equator and measure how far north or south of the equator a place is. Longitude lines are vertical lines that connect the North and South Pole. They measure how far east or west of the prime meridian a place is. The prime meridian is 0 degrees longitude. It goes through Greenwich, England, I believe, or somewhere. To locate a place on Earth, we use latitude and longitude lines. Now, a latitude line measures the central angle whose vertex is at the center of the Earth. Initial side is from the center of the Earth to the equator, and terminal side is from the center of the Earth to the given location on the Earth's surface. So latitude angles are measuring this central angle. For example, the city of Los Angeles has latitude 34 degrees north. This means the central angle formed from the equator to the center of the Earth to Los Angeles has a measure of 34 degrees, and of course that Los Angeles is north of the equator. Similarly, Reno in Nevada has latitude 40 degrees north, since the central angle formed from the equator to the center to Reno has measure of 40 degrees, and since Reno is north of the equator. If Reno and Los Angeles are on the same longitude line, how far apart are Los Angeles and Reno to the nearest kilometer? Assume the radius of the Earth is 6,400 kilometers. It's important that they're on the same longitude line, because if we go back to this picture, you see that if two things are on the same longitude line, then they are in a circle that includes the North Pole and the South Pole, and hence the center of the Earth. So it's almost like we can cut the Earth, slice it through the center, and find a circle that contains both of these cities. So let's find the distance. Since Reno is due north of Los Angeles, they both lie in a circle whose center is the center of the Earth and whose radius is about 6,400 kilometers. Thus, we're looking for an arc length between the two cities. Now we see how it's going to work. The difference in their latitudes, in this case 34 degrees and 40 degrees, tells us the measure of the central angle that intercepts the arc connecting the cities. So the measure of that central angle is 4 degrees minus 34 degrees, which is 6 degrees. We now know the central angle, 6 degrees, and the radius, 6,400 kilometers. But before we calculate the arc length, which is the distance between the two cities, we must convert the angle to radians. So 6 degrees times pi over 180 degrees would cancel the degrees and reduce to pi over 30. Now calculate the arc length. Our radius is 6,400 kilometers. Our angle is pi over 30 radians. If we multiply straight across, we get 6,400 pi over 30 kilometers. And we can reduce that by 10 to get 640 pi over 3 kilometers. But if somebody asks you what's the distance between two cities, don't tell them this answer. They'll think you're a big nerd. But your answer is precise, well, subject to the measurements of the latitudes. To the nearest kilometer, if we put this in a calculator, the distance between Los Angeles and Reno is about 670 kilometers. So it's just an arc length problem. You have to understand what latitude measurements mean, though. Now you try. Pause the video and try the following. The latitude of Memphis, Tennessee is about 38 degrees 8 minutes north. The latitude of St. Louis, Missouri is about 38 degrees 38 minutes north. To the nearest degree, both are on the same longitude line, 90 degrees west. I confirmed this on Google Earth. Using a radius of 3,977 miles for the Earth, calculate the distance between the two cities to the nearest mile. I will tell you that when you find the central angle by subtracting the latitude measurements, you will have something in degrees and minutes, which you should probably convert to decimal degrees before you convert to radians. Pause the video, give it a try. All right, here's your fair warning if you haven't paused the video yet. Solutions in three, two, and one. I do want to comment that I embedded the conversion from degrees to radians inside the calculation of the arc length, simply because this fraction would have a decimal on top if you didn't divide it out. But at some point, we're going to have to put it in a calculator anyway. I don't recommend approximating the angle before you put it into the arc length formula, because if you do, then you're using an approximate value of the angle, which might make your answer a little bit too inaccurate. So I embedded the conversion of 3.5 degrees to radians inside the arc length formula.